Subtopic of 8.2 Equilibrium of a rigid body. This is a top view of a door at living room. This picture shows two types of doors, where door A has a knob at the end of the door, while door B has a knob in the middle. Which door is the easiest to pull? Door A or door B? You will find that it's much easier to pull door A instead of door B, even though F is the same. This is because the moment arm D, door A, is greater than door B, you can produce a greater torque, and it's much easier to pull the door when the torque is greater. What happens if the moment arm D is closer to the rotation axis? If the moment arm D become closer to the hinge, the more difficult for you to pull the door. At this state, moment arm D is at the rotation axis. The door can't be opened. This is because torque is zero. You can't pull the door at the hinge. That is why our house door knob is at the end of the door. You will need greater torque to open your door. Torque, the symbol is tau, is defined as the product of a force and its perpendicular distance from the line of action of the force to the pivot point or rotation axis. For the door, the hinge is a pivot point. Line of action is line that parallel to the force or extend from the force. The distance between rotation axis or pivot point perpendicular to the line of action of force is moment arm D. F and D is perpendicular. Mathematically, tau is equal to Fd, where tau is magnitude of the torque, F is magnitude of the force, and D is perpendicular distance or moment arm. How to find torque when force have an angle theta? First, you need to draw the line of action of the force. Then, from the rotation axis, draw the line that perpendicular to the line of action. R is distance between the pivot point or rotation axis and the point of application force. From this diagram, shows that D is equal to R sin theta. We know that tau is equal to Fd. When we substitute D equal to R sin theta, we will get tau is equal to Fr sin theta. F and D is always perpendicular. Note that torque is equal to 0 when F is parallel to D.
This is another example for torque. Diagram shows two forces acting on a body. Determine torques acting on the body. Firstly, draw the line of action of the force, then draw the perpendicular distance D. Same goes to another forces. R2 is from rotation axis to the force 2. R1 is from rotation axis to force 1. We know that torque is equal to Fd, or torque is equal to Fr sin theta. Theta is angle between F and R. For force 1, torque 1 is equal to F1 d1, or torque 1 is equal to F1 R1 sin theta 1. Force 2, torque 2 is equal to F2 D2 or torque 2 is equal to F2 R2 sin theta 2. Another method is we can resolve component which is F2 become F2 sin theta 2 and the perpendicular distance D2 is from axis of rotation to F2 sin theta. Same goes to force 1, resolve the component. Then we can write torque 1 is equal to F1 sin theta 1 D1. Torque 2 is equal to F2 sin theta 2 D2. F and D is perpendicular.
Torque is also defined as turning or twisting effects of the forces on a body. SI unit for torque is Newton meter. Sign convention for torque, if the force is rotating anti-clockwise means that torque is positive. If the force rotating clockwise means that the torque is negative. For example, here we have two forces, which is push force. When you push the door will close. For pull force, when you pull the door will open. The arrowhead here is indicate the direction of the force will rotate. When the door being pushed, the direction of rotation is clockwise. The rotation of the force will create negative torque. While when we pull the door, the direction of rotation is anti-clockwise. The rotation of the force will create positive torque.
Example 8.1a. Determine a resultant torque of all the forces about rotation axis O in the following problems. Given F1, 30 Newton to the right, F2, 10 Newton upward, and F3, 20 Newton downward. The bullet green is the pivot point. We can start by draw the line of action by extending F1. Then we will get D. Same goes to F2. Extend the F2 for line of action. Then we will get D2. D1 is from the axis of rotation is 3 meter. D2 is 5 meter. For F3, D is parallel to F3. Now we need to find the direction of forces will rotate. From the pivot point for F1, the force 1 will rotate clockwise. Then, the torque sign convention is negative for clockwise. Now, for force 2, the direction is upward. Then, the force will rotate anti-clockwise. Then the sign convention for torque for anti-clockwise is positive. Torque will be positive. For F3, torque is 0 because F3 is parallel to D. This force can be rotated. For solution, you need to draw a table for first method consists of three forces F1, F2, F3. Then for F1, torque 1 is equal to negative because clockwise. Then negative 30 times 3, negative 90. Torque 2, F2, D2, positive because anti-clockwise. We get positive 50. Total up, then we will get torque is equal to negative 40 Newton meter. You can also write second method, which is total torque is equal to torque 1 plus torque 2 plus torque 3. Torque 1 is F1 D1 plus F2 D2 plus F3 D3. For torque 1 is negative because clockwise. F1 is 30, D1 is 3. Then plus Anti-clockwise is positive, then F2 10 times 5 is D2 plus 0 for F3 because parallel to D3. Then total up, we will get negative 40 Newton meter for total torque. Another example. Okay, for this example, the pivot point is at the center of the body. Again, for F1, we need to find the perpendicular distance, D1, and then we need to find the direction of the force will rotate. For F1, the force will rotate clockwise. Means that our torque is negative. For F2, torque is equal to 0 because F is parallel to D. For F3, we need to find the perpendicular distance D, and after that find the sine beta. Then the direction of rotation by this force is anti-clockwise, which is our torque is positive. Last force is F4. Torque is equal to 0 because F and D is parallel. For solution, we need to draw the table first, contain all the forces acting on the body. We have 4 forces there, F1, F2, F3, and F4. For F1, torque is clockwise, means that negative there. 30 is F1, 3 is D1, then we have negative 90 there. For F2, torque is 0. For F3, torque is equal to F3 R sine beta. Then F3 is 20, R is 5, sine beta is 0.515, then we will get 51.5. F4 torque is 0, then we'll total up all the torque, we will get negative 38.5 Newton meter. Or you can use another method, which is second method. Total torque is equal to torque 1 plus torque 2 plus torque 3 plus torque 4. Torque 1 is equal to F1 D1 plus torque 2 F2 D2 plus torque 3 F3 D3 plus torque 4 F4 D4. Torque 1 is clockwise, means that the sign convention it will be negative, then put negative there. F1 is 30, D1 is 3, plus F2 is 10, D2 is 0 because parallel, F2 and D2 is parallel, plus F3, D3. D3 is also equal to R sine beta, plus F4 is 25, D4 is 0 because F4 and D4 is parallel. Okay, substitute the value. For torque 1, negative 90 plus 0 plus F3 is 20, R given 5, sine beta as calculated is 0.515 plus 0. Total up, we will get the same answer as before, which is negative 38.5 Newton meter. A bowling ball, when a force is applied to it, does not easily change shape or break because a bowling ball is an example of a rigid body. Rigid body is a body with definite shape that doesn't change so that the particles that compose it stay in fixed position relative to one another even though a force exerted on it. If the body is in equilibrium, means that the body is translational and rotational equilibrium. We will learn about equilibrium of a rigid body. There are two conditions for the equilibrium forces acting on a rigid body. First is total F is equal to 0. Or we can write total Fx equal to 0, total Fy equal to 0, total Fz equal to 0. Another condition is total torque is equal to 0. Or we can write total torque anti-clockwise equal to total torque clockwise. For equilibrium of a rigid body, we have a center of gravity. For example, this ruler with 10 centimeter length. Center gravity or CG or center of mass is the point at which the whole weight of a body may be considered to act. For this ruler, 10 divided by 2, the center is 5 centimeter. Let's move to problem-solving strategies for equilibrium of a rigid body. First, find CG and sketch weight force of the body. To find CG, we need to find the length of the body divided by 2. The length of the body here is ruler 10 cm divided by 2 is 5 cm. Then we know CG at 5 cm. Draw the weight. The weight always directed towards the gravity. Second, sketch simple diagram that all forces acting on the body. After sketch the simple diagram, then draw free body diagram that all forces acting on the body. Last step is solve problem using two conditions for equilibrium of a rigid body, which is total Fx equal to 0, total Fy equal to 0, total Fz equal to 0, and total torque equal to 0.
Let's move to example for next video.